Next examples, uniform flow determine the flow depth. So in this case, the cross-section of the channel is the same, okay? Given the flow rate is 10 cubic per second, the canal running is changed to VD. Determine the depth of the flow, okay? For that is the given the flow is 10 and VD. So we can have to find what is the manning end for VD. So in this case, is the VD is classified in the evacuated earth channel. Manning end is 0.03. Okay, so we can manning end is 0.03. Okay, and we can write the geometry parameter for geometry of the trapezoidal. For the x is a function of y. Now we don't know y, so and we can write the L, the inclined length is a function of y is equal to 1.56y, and is also the right equation of area. Okay, the area is make rearrange this equation to get okay, and finally is equal to 1.19 y squared plus the 4y, and find the velocity equation for the weighted parameter is 4 plus 2 times of 1.56y is equal to 4 plus 3.11y. Again, and when we finish the our parameter for the open channel flow, we go to the manning end. Start from Q is equal to 10 is equal to this parameter equation. So we can 10 is substitute all number in this equation for the manning end, area, and weighted parameter is area over P, and slope is 1013. And we can make its simple form is equal to 1207A equal to this one is just combine A is just still to be the radius. The next we don't know how to what is the y depth, because we have to use method of the trial and error method. We have to assume y and check q equal to 10 or not. So we can make a table and start from y, and when we know y, we can know area, we know the better parameter, and we know the and finally we know q. Okay, so we can try first. For example, for y just set 1 meter. So we can, what if we try 1 meter, we know the area is 5.19, and weighted parameter is 7.11.11. Hydraulic radius power 2 or 3 is about. When we substitute in equation, we got q is 5. So this is too low. So we may try to increase the depth 1.2 and do again for area. he increased to 7.2 is still too low, so we have to increase more, increase the depth. Another try. See that is now is too high compared to given 10, so we have to reduce a little bit to 1.45. Okay, it's still a little bit too low, so we have to increase to 1.47. Okay, it's very close enough, so we can good enough, so we can come up with a solution that y is equal to 1.47 meter. Okay, and then some notes at the bottom. In many man-made channel and most national channel, the surface roughness or Manning coefficient vary along P of the channel. If we divide the channel cross-section into n, so if the n is vary, so we can divide into subsection, each with own weighted parameter P and own area, and the Manning Ni. And the Pi value does not include the imaginary boundary between the different subsection, and total flow is assumed to be the sum of the flow rate through each section. So I will show you next example on this explanation